Today, we're going to pull back the curtain on one of the biggest buzzwords in tech, large language models. If you've ever found yourself wondering what's really happening inside something like ChatGPT, then you are in exactly the right place. Let's dive in. So, picture this. You ask an AI to write a poem, maybe an email, or even some code. And then, boom, seconds later, a surprisingly good answer just appears. It honestly feels like magic, right? But how? How does a machine actually come up with those words? Well, at the heart of it all is something called a large language model, or LLM for short. So what is it? It's basically an AI that's been trained on a truly mind-boggling amount of text. We're talking the internet, books, articles, you name it. This doesn't teach it to think like a human, but it gets incredibly good at recognizing patterns, grammar, and how words relate to each other. I love this analogy from IBM. It really nails it. Think about the autocomplete on your phone, when it suggests the next word. An LLM is basically a supercharged, genius-level version of that. It's just predicting the most likely next word, or token, one after another, to build whole sentences, paragraphs, even entire essays. And you've almost certainly used one of these without even thinking about it. We're talking about the big names here. ChatGPT for writing, well, anything, Google's Gemini, Llama from Meta, and even super specialized tools like Copilot, which is a total game changer for programmers. They are already a huge part of our digital lives. All right, so how does that magic, that whole next word prediction thing, actually happen? Let's take a little peek behind the curtain and see what's really going on. It really boils down to a three-step process. First, you've got pre-training. This is where the model just gobbles up billions of sentences to learn word probabilities. Then, the secret sauce, the transformer architecture. This is what helps it understand context, not just the word that came before, but the meaning of the entire paragraph. And finally, the prediction mechanism puts it all together to generate what it thinks is the most likely sequence of words to answer your question. Okay, so now that we know how they work, how do we get them to work better for us? This is where a really cool new skill comes into play, prompt engineering. It's all about learning how to ask your question in just the right way to get the best possible answer. And this shows you the difference perfectly. A weak prompt like, tell me about AI, that's just way too broad. You're going to get a super generic, probably useless response. But look at the better prompt. It's specific, it says what it wants, an explanation, it defines an audience, computer science students, and it asks for a format, examples. Seriously, the quality of your output is directly tied to the quality of your input. So here's the pro tip. Be specific. Give the AI a role, like act as a professional copywriter. Give it context, like I'm a small business selling handmade candles. And give it a clear goal, like write 3 Instagram post captions about my new lavender scent. The more guardrails you give it, the better and more on point the answer is going to be. But there's a catch. Most LLMs are trained on a fixed data set, which means their knowledge has a cutoff date. They don't know about yesterday's news. So how do you get real-time info? Well, that's where this really clever solution called Retrieval Augmented Generation, or RAG, comes into the picture. Think of RAG as giving the LLM a library card to the live internet. Before it even starts to write an answer, it can go out and search an external, up-to-date source of information, like the web or your company's latest sales data, to find the most current facts. A normal LLM just couldn't answer this. How could it? The price is changing literally every second. It would just have to guess based on whatever old data it was trained on. So how does RAG handle a question like this? Okay, so the process is actually pretty straightforward, but so powerful. First, you ask the question. The RAG system then instantly searches an external database for the latest info. It grabs that relevant fact, the current price, and then it feeds that specific number to the LLM along with your original question. Armed with this fresh, live data, the LLM can then generate a perfectly accurate, context-aware answer. Problem solved. Now, this technology is incredible, but it's not perfect. Not by a long shot. In fact, it has this one really weird and sometimes dangerous flaw that we have to talk about: the phenomenon of AI hallucinations. So, what is a hallucination? It's when an LLM spits out an answer that sounds completely confident and plausible, but it's just wrong. It can invent facts, make up sources, or create details out of thin air that seem totally real but are completely fabricated. Let's look at a super simple example. We ask the AI a straightforward trivia question. I'm guessing a lot of you watching know the answer to this one.
An LLM might confidently tell you it was J.J. Abrams. And you know what? That sounds reasonable. He's a famous director. He does sci-fi. The name just kind of fits the pattern. But it is dead wrong.
Of course, the correct answer is the Duffer Brothers. And here's the absolute key thing to remember. The AI isn't lying. It's not trying to deceive you. It's just predicting what it thinks is a statistically probable answer based on all those patterns it learned. It doesn't know facts. It just predicts words. So how in the world do we protect ourselves from this? Well, there are a few things. First, go back to prompt engineering. Make your prompts as clear as possible. Second, use a technique like RAG to ground the AI's answers in a specific set of real, verifiable facts. And finally, for anything really critical, like in medicine or finance, you absolutely have to have a human in the loop to review the output. It's just non-negotiable. And all of this leaves us with a really big, kind of philosophical question. As we start relying more and more on these amazing tools that are fundamentally just sophisticated pattern predictors, not keepers of fact, how does that change our relationship with information? And maybe more importantly, what does it mean for our own concept of truth?